Trigonometric substitution example. To integrate 1 over x squared minus b squared, substitute in b secant theta for x, and also integrate in dx, and the derivative of b secant theta is b secant theta tangent theta d theta. After substituting in for x and dx in terms of theta, we see that we can simplify the denominator, and the denominator becomes tangent theta. And then this expression, we get an expression that we can easily integrate. So after substituting in for x and dx and simplifying the denominator, we get the expression secant theta d theta. So all we have to do is to integrate that using a table of integrals. We get the natural log of secant theta plus tangent theta, plus a constant. So remember, we substituted in b secant theta for x. So we have an expression relating theta and x and b. So we want to find out what secant theta and tangent theta are in terms of x and b. And using the triangle, we know that secant theta is x over b, and tangent theta is the square root of x squared minus b squared over b. So, substituting our expressions of x and b for our secant theta and tangent theta, we get the solution, and we get the integral of the square root of 1 over x squared minus b squared is equal to the natural log of the absolute value of x plus the square root of x squared minus b squared over b plus a constant. I suppose what you substitute in you have to memorize, but when you have the following in the denominator, this is what you substitute in, and once after your substitution, it's straightforward.